Alright, so it's Wednesday, BCA. First of all, Tech Den this week, Friday the 13th. We're doing 9 a.m. We're doing Cloud, AWS intro, and then at 10 we're doing Blender, getting started, 3D modeling. Alright, so if you can make it for any of it, part of it, or all of it, that would be great. Next thing, by the way, so we are, how many weeks left? We have 4 weeks left, okay? So, here we go. Introduction to computers, basic events, and tools. We did a little review, talked about authentication, authorization, and accounting. We talked a little bit about HTTPS secured. We talked about digital signature, public-private keys, and then got going on database work. Here's where we started out. We started out talking about data. Data cryptography. We talked about data being stored, data in transit, data being processed, accessing data and information, and so forth. So let's talk a little bit about it again. Data integrity. Is the data accurate? Data confidentiality. Who can see what data? Okay? So, confidentiality. For example, cryptography. We can encrypt the data so that people cannot read it. And we can encrypt it when it's stored. We can encrypt it while it's being transported. Here, when it's being processed, it can't be encrypted, basically. Alright. Now, integrity, we can hash the data on one end, send the hash, and then here's the data, send the data. When the data gets to the other end, we can hash it, take the hash we brought over. If they're equal, then the data's integrity was preserved. It wasn't changed. Okay? When we access data, we can authenticate. We can by who we are, something we have, or something we know. Face print, fingerprint, all those things, who we are. Something we have, we can have a fob, we can have a debit card, and so forth. Something we know, a password, a user ID, a PIN, and so one or a combination of those, we can authenticate who we are. Once we authenticate, the computer system can authorize what we can do, and the computer can keep track of what we did. Pretty basic things in security. Now, let's talk about products. All these P's, products and devices. We have firewalls, this idea things trying to come in, we can block, but we allow things out and back in. Okay, so we have firewalls. We can look at once some intrusion occurred, we can have intrusion protection, or intrusion detection. We can check inside our network and make sure some hacker is not in there. Defense we have spyware, virus software, and so forth. Okay, people are key to security. We can have policies that people should follow. We can have guidelines that people follow. Security policies. For example, we talked a little bit about Facebook these last couple days. And then people need to know how to keep their stuff safe. So you have procedures. You follow these procedures. Like how to change your password. You might have a guideline. You'll change your password once a month. And then the procedure shows you how to do that. All these P's you could think of are protecting our data. Good review sheet. Alright. more information. So here we did an example. First of all, this green box is our data. And we want to send the data from home to Rudd. So we use Michaela is going to send the information to David. So she's going to send this data, maybe through the internet, to this location. So one thing we can do is we can encrypt the data. We can have a key on this end, encrypt it, and use a key to decrypt it. That works good as long as you can have what they call shared keys. Okay, we use a key with an algorithm to encrypt the data. Shared key. Now, we can also do this. Let me use a different color here. We can hash the data. So here's the data. Here's the hash. We can send the hash over. When the data gets to the other end, David can hash it and compare it with this hash. If they're equal, the data hasn't changed. Alright. Now, exchanging the keys can be a problem, so what we can do, we can have public and private keys. So, David can send his public key to Michaela, okay, and Michaela can encrypt the data with that public key, send the data over, okay, to David. And then David can decrypt it with his private key. Does that make sense? Because a key pair, only this key pair can be used to encrypt and decrypt. Since it's a public key, you can send it over. Michaela can encrypt it with the public key, send the data to David, and then he's the only one that can decrypt it with a private key. You never give out your private key when you have a key pair. Now, in the other scenario, let's do this one in green. Okay, Michaela can take, here we go, she can take her private key and let's say create a digital signature. She can take the hash, encrypt it with her private key, send that digital signature over, and send over her public key. David can use the public key, her public key, to decrypt that information. Now he has that hash. He can hash the signal, the message that was sent, and see if they're equal. If they're equal, it had to be okay. So that's like a digital signature. It is a digital signature. All right. Man, that was a lot. But that's how it works. Last thing, we're going to do some database work down here. Alright, so that's what we did. Created a table. Entity, students is the entity, and these are the attributes that describe a student. Okay? I was going to look and see if NIAC collects the social security number from everybody. So we have a student ID, their name, and then this other information. This would be a record. And so we have all these records. These are fields or attributes. I'll call them attributes a lot. Okay, records. And we have a table, an entity. In this entity we have a primary key. Student ID would be unique for each student, so that would be a primary key. Alright, so we do the same thing. A faculty table, primary key, and then other attributes that describe faculty. And in this case, I got my faculty number, 007. Here's another faculty number, 99. Okay, information about us. These are records. These fields are attributes, define faculty. And we did another one. For courses, course ID, primary key. I'll do that in red again. Primary key. How many credits? The instructor. Now this was interesting. For the instructor, I put in a number. I got that number up here. So here I can just put the number, and that points to the instructor up here. So for example, if I change my address, I only need to change it here. I don't have to change it down here in this table. Description of the course and so forth. So again, we have records, attributes or fields, all defining this entity, courses. One more table. So in this table, we have the current schedule. So we have current schedule ID, and then we have student ID. Came from up here. Since this key came from another table, primary key, this becomes a foreign key. Is that right? It's hard to read that. Anyway, it becomes a foreign key. How do you like that? Alright. So, do you see another foreign key? Yeah, we have this situation here. Course ID. From right here. So then this is more like an active table. It has the current term. So let's say you have, so I'm going to use another color. Can you believe it? Let's say you want to know which students are in which classes. You could look here and find the student ID, and then if you need to know the student's email, you could use that then to come up here and get it out of their table. Find information about the instructor. This would take you over to this table, and this table then would take you to the instructor. If we changed instructors, all you got to do is change it here and add the new number, and everything is good. These are called relational database management systems. And to finish up with, we had the voters, group work. And so you can see here, there's a lot of records in that voters table. Alright, finish up the unit on Friday. That is it.